morning. Our lesson today, Algebra, is on looking at percent change and just thinking about how that helps us work with exponential functions. So it's going to be, again, partially a review. A lot of it is actually you're calling 7th grade percentages. A lot of the stuff deals with money and percent increase, percent decrease. So it's going to be a little bit of a review for some of you, a much needed review, but a lot of realistic applications. So let's get started. Again, we're following lessons 14 and 15 from Illustrative Math. And one more thing I'll mention is that this exit slip for today is going to have a password somewhere in the video. I'll show it with pretty much no warning for like 2 seconds, and then your exit slip won't begin until you get the password. All right, so wheels. A scooter costs $160. For each question, show your reasoning. The cost of a roller skates is 20% of the cost of the scooter. How much the roller skates cost. So these 3 questions are like the warm-up. So give it a try. Pause it now, give it a try, and I'll show the answers in just a sec. Okay, so here's our answers. The roller skates is 20% of the cost of the scooter, so it's only 20% of the scooter. So that's much less than the scooter. So a lot of this is like thinking about numbers sensically, if these numbers make sense. So 20% of the cost of something is like less than a quarter of the cost. It's 1/5 of the cost, so it's much, much, much less. So it is 20%, 20 over 100 times 160 gets me 32. Or I could do 0.2 times 160 gets me $32. So either of those methods works. Number 2, a bicycle costs 20% more than the scooter. So 20% more than means I take 20% of it and I add it to my original. So that's the 20% right here, and then I'm adding it to my original. Gets me $192. Or the shortcut we're going to learn today, and I'm going to star this method because this is what we're going to sort of focus on getting to today, is if it's 20% more, it's really the original plus 20%. It's more than the original price. So it's 160 times 1.2, 20% more, gets me $192 in one step. And when we write functions, they're going to look like this. So please make sure this is there. A skateboard costs 25% less than the bicycle. How much does a skateboard cost? And I know we've talked about this a little bit in our functions. So we could take 25% of 192. Now, the bicycle was 192. And that'd be 48. And then subtract that 48 from the original. That's very logical. But what I like to do is, again, say, well, if it's 25% off, then you're paying 75% of the original price. So 192 times 0.75 gets me $144. So we're going to use that kind of thought processing in a lot of today. So make sure you have that at the very, very least as we head into the next section. Taxes. Yes, taxes and discounts are almost all percentages. So you need to pay 8% tax on a car that costs $12,000. What will you end up paying in total? And also, these are more that you can just do on your own. So again, pause the video here, and I will show you the answers when you're all done, okay? All right, so just a little bit more of the same. Sales tax works the same way. It's 8% added on. So 8 out of 100 is 8 hundredths. 12,000 times 8 hundredths is 960. So 12,000 plus 960 in tax gets me that total. Or, again, the better method, multiplying is the only step. 12,000 times 1.08 gets you 12,960. Burritos are on sale for 30% off. Man, I wish, right? 30% of 8.5 is $2.55. Subtract $2.55 from $8.50 gets you $5.95. Or better yet, 1 minus that 30% gets me 70%. I'm paying 70% of the price of this burrito. 70% of $8.50 is $5.95. This is the work I want you guys copying down, or, well, if you haven't printed it yet, committing to memory. A pair of shoes that originally cost $79 are on sale for 35% off. And I didn't read the directions here because, oh geez. Does the expression 0.65 times 79 represent the sale price of these shoes in dollars? Yes, it does. And instead of explaining, we're just going to show why it works. Because it does. All right. All right, this is such a good question, but we are going to skip this one for now. We're going to come back to that. It's kind of our exit slip later. So expressing percent increase and decrease. Complete the table so that each row has a description and 2 different expressions that answer the question asked in the description. So This is a good way of connecting the two things we talked about last activity. So the first one expression is just, okay, the $160 original price for that hotel in Anaheim. That's where Disneyland is actually, so Disneyland Hotel, when they ever reopen it. Hotel room occupancy tax is 15%. What is the total cost of a one-night stay? So again, it's taking that original and it's adding 15% of the original for tax. So what I can do instead is, actually, I'm gonna have you pause this right now so you can do it on your own. All right, but we're gonna write an expression in only one, with just multiplication. All right. Hopefully you're able to get through most of these. You might have had trouble coming up with a word problem for this last part. And this last one, I had trouble with this bottom left column because I'm just so used to dealing with exponents. So, real quick, that expression up here should have been 160 times 1.15, increasing by 15%. And then over here, we had 24 minus 30% of 24, because 70% is what's left. We lost 30%. All right. Population of a city, 842,000. It was 842,000. And increased by 2%. And by golly, I did this wrong again. Over here, it should be 0.02. I did it right over here. 842,000 times 1.02. And 90,500 for the major hurricane lost 46% of its 90,500 households. Well, they lost their electricity at least. So we lost 46% of that 90,500. How many still have electricity is 54%. We lost 46%, 54% remains. Marcus had a bill for $754, but paid 21% of it. How much remains to be paid? I came up with that because he started with $754, but then he lost 21% of it. So he paid 21% of his bill. That's good. So only 79% of it remains. All right, and if we did the math here, we'd find, I don't know, some amount of money less than that. And then, okay, 2 years ago, the number of students in a school, this one's a little challenging, was 150. Last year, the student population increased 8%. This year, it increased about 8% again. So this expression over here looks really bad, and that's why we want to make sure our equations involve this, because this is so much neater. So our equation, our expression on the left is 150 from the first year. 150 times 0.08 is the increase to year 2. And then we need to take this whole thing, because that's our new total for year 2, and that whole thing gets multiplied by 8% again. And this whole thing is the increase, that whole bottom line is the increase to year 2. Or we can just multiply by 1.08 and then multiply by 1.08 again. Which, I mean, come on. You can't beat that. All right, so there's that one. And now we're going to talk about our strategies for mentally adding 15%, because no one wants to whip out their calculator when they're shopping to figure out what 15% is going to do to their total. So let's just say, for example, I've got like, I'll pick 48. It's not a terrible number, but it's like a realistic number. So, for mentally adding 15% to the total cost of an item, and I know what you're thinking. You see mentally, you see 15, you see percents. You're waiting for me to just do it for you. That's fine, whatever. Let's talk about strategies. So, 15% of a number. Well, that's really 10% of a number and 5% of a number. So what's 10% of 48? Well, it's a tenth. So I gotta move that decimal point over one place. So it's 4.8. And what's 5% of a number? Well, 5% is half of 10%, because 5 is half of 10. So 4.8 divided by 2 is 2.4. So if I'm adding 15% to a number, I'm really doing 48 plus 4.8 plus 4. Isn't that cool? Which gets me, all right, 48 plus 4, 52.8, 54.8, 55.2. All right, awesome, awesome. Your password for your video is glazed, Glazed, like the donut I had to buy Sebastian this morning. Okay, next part of the lesson. All right, these dandy discounts. All books at a bookstore are 25% off. Peyton bought a book originally priced at $32. Ronan, the cashier, applied the store-wide discount and took another 25% off using a coupon that, oh, Dan changed the name to Peyton again. I'll change it when I upload it. Peyton brought. If there was no sales tax, how much did, dang it, Peyton, pay for the book? Show your reasoning. So honestly, I think what we're going to do is we are just going to let you work through this whole page. And I'll go through the answers at the end. All right? So pause it, and I'll go through the questions at the end. Okay, this dandy cashier, Ronan, made her pay 75% of the original price because it's 25% off. And then she had a coupon for 25% off. So a coupon that says I am only going to pay 75% of that remaining amount. So she ends up paying $18 for that book. Kristen, a recent college graduate, charges $850 to a credit card with 18% interest. That's fairly typical. So how much will she owe at the end of 1 year? Again, so we're adding 18% interest, so 1.18. Gets you $1,003. Assuming she'd be allowed to continue to make no payments to the lender and not be arrested, which is not a very good claim to make. You would definitely be tracked down if you're not paying credit card for that long. Well, 2 years, 1.18 times 1.18 again. Gets me $1,183.54. And then after another year, another 18% interest. So they're definitely tacking on late fees by now, but whatever. $1,396.58. It's the danger of credit card debt. To find the amount owed at the end of the third year, a student started by writing this. Year 3 amount is the year 2 plus 18% of the year 2. And ended with, and I don't know which students these are. I don't know these students. They think the long way for sure. But whatever. They thought 850 times 1.18 times 1.18 times 1.18. And that, of course, will work. That's pretty much exactly what I wrote up here, just in expanded form. So yes, that'll work because we started at 850. 18% for year 1, 18% for year 2, 18% for year 3. And then this is like the where are we going with this? Oh yeah, look at that. We got a nice exponential function just without the equal sign. And the last class activity for today is just comparing different loans and seeing how dangerous certain types of loans are. So suppose 3 people have taken loans of $1,000, but they each pay different annual interest rates. And you'll hear people talking about interest rates, and with a certain situation going on in the country, interest rates are falling, which is good, but that also means that, well, you know, there's different things at play. So typically, banks don't give you terrible loan rates, like whatever, 12%, not a bad loan rate, depending on what you're buying. For a house, it's terrible, but for certain things, not terrible. A used auto loan, typically auto loans are lower than this, but if you're getting a cheap car on a loan, like if you're spending $1,000, that's a reasonable rate for if you're taking out $1,000 for a car. And a credit card, you should never pay 33% interest on pretty much anything, or that's called predatory. That's like taking advantage of people. So anyway, for each loan, write an expression using only multiplication for the amount owed at the end of each year if no payments are made. If there's any part of this lesson you should do, it's this one. All right. Although if you've made it this far in the video, you've probably done everything else. Still, this is one of the more important ones. So you want to do this again on your own. You're going to pause the video and I'll upload the answers. But you want to figure out for how many years without payment. What's your balance here? What's your balance here? What's your balance here? What's your balance here? After 1, 2, 3, and 10 years, and write the equation. All right. So I'll just write the equation for this one. 1,000 times 1.12 to the x power. And then down below, you want to see how long it takes for your unpaid balance of your loan to double, because exponential growth gets pretty scary, especially when talking about stuff like this, how quickly the amount you owe can double. All right, use any of the strategies. You use a table, you can use a graph, or you can use some equations. You can just plug in some numbers, trial and error. I'll show all of them. You don't have to do all of them. Give it a try. So for this, I use the Desmos Scientific Calculator, and I'll just show you what my screen looks like really quick and how the calculations can be done so easily. So pardon the wobbling. But when I see my calculator, if I got my third equation, for example, was 1,000 times 4/3 to the 10th. That gives me that value on the table. That's the first year. I just backspace the second year, the third year, and oh look, it's already more than 2,000. It's already doubled. And I can just, all right, I can just change whatever I need to in here. So if I could go back and do my used auto loan at 1.2 is my growth factor. And see, all right, exponent of 1, that's 1 year. 2 years, 3 years. It's so easy. Please use this calculator if you can. It's here. Anyway, back to business. So, I figured out my numbers. The predatory card took less than 3 years to double its worth, which is why credit card debt is so scary. The used auto loan, it's almost there, and we'll find that after 4 years, my messy graph, after 4 years, my auto loan was worth $2,073.60. So it's just before that 4th year. So I guessed about 3.9 years. And the bank loan, that's that bottom line here, took me between 5 and 6 years to get doubled. I don't have the exact numbers on me, but I could look at my Desmos calculator again if I really wanted to, which I guess I do. Why not? So there's my third year, 1,404. There's my 4th year. There's my 5th year. There's my 6th year. Looks like I was wrong. Between 6 and 7. Yeah, between 6 and 7. So it really should be like 6.2 or something. I was fairly generous. But on my graph, like if you showed me that work on your graph and that was your line, that'd be okay. If I asked you to use a calculator, this would be better. So it really should be between 6 and 7. So I'm actually gonna modify that to be between 6 and 7, like 6.2-ish years. And I'll go fix my graph so it more or less models that same growth pattern. Yeah, this looks like Mr. Roboto work now. It's super messy. Looks about right. And look, it goes right about 6.2 right here. So it hits 2,000. All right. So very good job. Your regular slip should hopefully go a little bit better than yesterday's. I'll try to make it just like this. So if you saw the video, you are prepared. All right? Good lesson today.